So octopuses actually have an amazing circulatory system with 3 hearts and blue blood when it's oxygenated. So first of all, octopuses and humans both have a closed circulatory system. So their blood is contained within closed blood vessels such as veins, arteries and capillaries. And this is as opposed to an open circulatory system where blood just fills up body cavities and is in direct contact with the body tissues. So in closed circulatory systems, blood is filtered before it comes into contact with body tissues. So octopuses and humans both have veins, arteries and capillaries. So closed circulatory systems allow the blood to flow at a much higher pressure than open circulatory systems. So octopuses are ectothermic, so just cold-blooded, but they do still have quite a high blood pressure, which can exceed about 75 millimeters of mercury. So for a comparison, a human's resting blood pressure is about 120 over 80 millimeters of mercury. So blood in octopuses and humans carries out functions like supplying oxygen to tissues, carrying nutrients to cells, and removing waste. So human blood contains the oxygen transporting protein hemoglobin, and this makes human blood appear a bright red when oxygenated and a much darker red when deoxygenated. Now octopuses instead have an oxygen transporting protein called hemocyanin, and this makes their blood appear blue when oxygenated and colourless when deoxygenated. So hemocyanin in octopuses is dissolved in their blood plasma, whereas in humans, hemoglobin is contained within the red blood cells. So hemocyanin is copper-based, whereas hemoglobin is iron-based. So hemocyanin contains 2 copper atoms, whose oxidation states each go from +1 to +2 when they each bind to a single oxygen atom, and this is what's responsible for hemocyanin's different colours. So as well as hemocyanin, octopuses also have hemocytes, such as blood cells, in their blood, and they act as part of the immune system, like white blood cells in humans. So octopuses don't actually have platelet-like structures in their blood that would make it clot. They instead close up wounds with a cellular plug. So hemocyanin is generally roughly a fourth as efficient at transporting oxygen than hemoglobin. However, hemocyanin is more efficient than hemoglobin in colder climates and low oxygen environments. So an octopus's 3 hearts are located in its mantle, which is just behind its head. So octopuses have a systematic heart and 2 branchial hearts. So the branchial hearts contain a single chamber, and each one pumps deoxygenated blood to a corresponding gill. The blood becomes oxygenated and then travels from the gills to the systematic heart, where it enters through 2 chambers called atria and then passes into a chamber called a ventricle, where it is then sent to the rest of the body. And then the blood finally returns to the branchial hearts after becoming deoxygenated. So the blood enters the branchial hearts through veins called vena cavae and leave through an artery called the branchial artery. So branchial just means relating to the gills, whereas pulmonary means relating to the lungs, which is why humans have blood vessels called pulmonary veins and pulmonary arteries. The vein blood enters the systematic heart through is called the branchial vein, and the artery it leaves through is called the aorta. So the systematic heart is actually inactive while the octopus is swimming, so it generally prefers crawling along the ocean floor, so it doesn't tire out quickly.